Good morning, guys.
Oh,
As has been usual these days, core is going over. While we wait for them, Casey, are you have a mic available?
Yeah, hey Mark. How have you been?
I see you unmuted, but I don't hear you.
Testing? Nothing?
Hmm, maybe it's on my end. Igor, could you? No, yep, it's on my end. Sorry, I'll be back, guys. Okay, trying again. Casey, could I get you to try talking quick?
Testing.
Yeah, there we go.
Can you read me? Hey Mark,
I
what's up?
can. Oh, lots of stuff for Pacific right now. But I had a question for you that when I saw you, I wanted to bring up. Um, I made a PR a little while back for uh, RGW that shards the object cache, and I was wondering if I could convince one of you guys to take a look at it. This is just kind of sitting there. Let me link it. Second.
This is RGW's metadata cache.
Yeah, here. It's really stupid. It's basically just wrapping the existing cache and making shards from the existing implementation. I know Matt really wants to redo all of this, but this might be like a stopgap that could be used for a while until you guys have time to do that.
Huh. So you're seeing wins from this? It eliminates lack contention?
I think so. It's been a while since I looked at it, but I think it did. Did I put anything in the comments? I remember having this be useful when I was looking at RGW a while back. Yeah, small object would get delete workloads. There was lock contention apparently. But yeah, take a look. I mean, see if it looks like it might be useful to you or not. Yeah, up to you guys.
Um, I guess my first impression is that I would rather avoid complexity there and unless we can show wins. Um, so I mean, do you still have any of the data where we had evidence of lack contention?
I can go back and look. I'm trying to remember what it was I was looking at that point, but I probably have data somewhere.
Okay. And I see that it changes a shared lock to a exclusive
Yeah,
lock.
I think you guys should do that anyway. That was surprising. I don't think it's giving you the win that maybe the original thought was that it would give. But anyway, we can talk about that
Well, I mean,
later.
metadata in RGW changes very infrequently. It's like when you create a new bucket or a new user. And so I would expect this to be read mostly. And so allowing multiple readers at the same time seems like what we want there.
There was, when I was going through and looking at this, I was actually going back and looking at a bunch of um, like documentation and tests from people looking at shared locks versus exclusive locks, and kind of the gist seemed to be that shared locks, kind of generally speaking, aren't even wins in the cases where you'd think they'd be wins. But I mean, I don't know how much it actually matters.
Yeah, I think I'd want to see at least some data to support that before making changes like this.
Sure. Okay. Well, yeah, maybe, I mean, like I said, it's totally cool either way. I just didn't want this thing sitting out here. If it's worthless, I can just close it out. But totally up to you guys. All right. Well, I think we got people from core starting to come and show up here. So let's see. We've got 5 new PRs that I saw this week. Uh, let's see. There's a couple from Igor and Adam about incremental update mode for Bluefs logging. Uh, one of you guys want to talk about it?
It's basically adding a new op for Bluefs log that for cases when we just modify content size for file or just add one extent, we just serialize only reduced amount of information. So we just add a new extent if it's present and update modify time and update size. That's basically all. There are 2 pull requests because currently with Igor we talk which solution is nicer. One will go in and the other will die. That's how it will be. The reason is to reduce speed of Bluefs log growth. That's it.
Yeah, and I believe the final approach would be the Adams PR, which incorporates both my and Adams commits. Maybe some minor cleanup is required there, but generally it's okay.
All right, cool. We've got a PR from Kifo that reverts the change that made it so that we were always building debug builds from source. So that's good. I think that probably maybe confused some people on testing, possibly myself included, in some tests over the last couple of weeks. Mark Kogan discovered that, so kudos to him. So that should basically fix that change. Then we've got a couple of additional PRs that are aimed at changing the way that the deferred IO path works, which we previously had changed between Nautilus and Pacific. The gist of this is that right now, when running on hard drives, we see really a huge amount of write amplification in RocksDB because we are deferring even very large writes with the way that master currently works. Basically, anytime that the preferred deferred size is the same as the blob size, we basically defer all I/O. So we'll talk about that more in a little bit, but these are both different PRs that are aimed at improving that. Okay, updated. This MDS lock switching to fair mutex. That a review has been requested from Patrick. Keith, who previously reviewed it. RGW tracing. Casey, it looks like I think you're still reviewing that, right?
Yeah.
Okay, cool. Radix optimization for carriage handling and buffer list. It failed QA. Keith had run that through tests, so I guess that just needs another look. Adam, it looks like you updated your Bluefs fine-grain locking PR.
That's correct. This week I was doing that delayed self-review, finding some missing parts in logic and some inconsistencies, still not to be merged yet and not seriously reviewed by anyone else. Will be soon.
Sure. Okay, and then it looks like there's also further review being done on this OSD compression bypass after RGW compression PR. And let's see, no movement. I've got a couple of things in here that I need to go back. Memstore refactoring cleanup, that can, I don't know, it could probably just be merged now. I can switch it from do not merge to merge. I did want to maybe do a couple more things on that, so we'll see. What else? Oh, Igor, I think your PG removal optimization for PG removal PR needs a rebase and was failing tests, I think.
Yeah, that's on my plate.
Okay, cool. Adam, for the TC Malik change, your PR, what do you think? Do you want to keep trying to go that route, or do you think we should?
I'm really agnostic on that. I just want to have the proper memory given to tcmalloc cache, and that's it. Whatever we decide, I really don't have a personal opinion on that.
I think you had a really good idea with it. If we can set it inside Ceph rather than relying on outside tools setting it, I mean that's really nice.
So should I rebase it and put it forth for current discussion?
That's what I was just going to ask Sage, because he's the one that worked on the other one for the stuff admin, right? Like the PR to set it there. I mean, do you want it? Would it be worthwhile or useful for you if we could just set it directly in the OSD itself with like a config option? I don't hear you, Sage.
Which one is this? This is 41804, the TC Malik max thread cache bytes.
Yeah. So Adam made a PR that lets you just set it directly in Ceph, for a config option.
I think that would be much better. Yeah.
Yeah. Okay, Adam, sounds like we've got the seal of approval. So I think it's a good idea.
Mm-hmm. Yep.
All right. I don't know. There's a bunch of other stuff in here. I still need to go back and do cache binning. Get back to that. Yeah, I don't know. Probably not much else in here to talk about now. All right. So, anything I missed from anybody on the PR front?
My PR was included finally.
Yours was included? I thought I always included yours, didn't I, Gabby? Oh, you mean merged?
It's finally committed.
Oh, fantastic! That's great. When did that get in?
Yesterday.
All right. We should be seeing a really good performance bump with that then. That's excellent.
I hope that small right would be helped.
Yeah, absolutely. There's another regression in master somewhere that I need to track down that kind of came with all this deferred right testing that I had not uncovered yet. But hopefully we'll soon. And then I'm excited to see once we get that fixed where your PR ends up landing in terms of making the right path faster for small writes. Very exciting. All right.
There was another PR that actually was merged last week after a year of the on-wire compression that I see somehow was missed somehow in the. It appears on the pad as if it was closed, but there is different number. But we added on-wire compression. So on the pad it appears on line 1407 as closed. But it's a different number. The number of this is actually 36517. That's what eventually was merged.
Okay. Let's see. Yeah, that's the other one. Maybe never made it into the pad. Well, that also is exciting. That's good. Yeah. I guess I just missed that one. All right. Well, yeah, that's great. So, if we don't have any other PRs, then the only big discussion topic I had for today is that we're trying to figure out for deferred IO fixes in BlueStore what approach we want to take for master and what approach we want to take for Pacific. So internally, the last day we've been talking about the different options that we have available, and I think for Pacific, we're kind of leaning towards a minimal patch set that doesn't change things too much. We were throwing around the idea of fix 5 from my commit series, which is just a one-liner, and then possibly Adam's PR that he made, which I believe is 42.721, or maybe just a portion of that. Let's see, that is, here's Adam's. Fix 5 from mine. Is here. Okay, so in the testing that we did, multiple of these kind of maybe have overlapping effects. They all make the amount of write amplification and writes going into the write-ahead log and mem tables and rucks to be much lower than they are without them. Arguably, they may not be quite as good as we could get it, but they'll certainly have a big effect. Adam, I wanted to ask you, you mentioned wanting to get your PR into Pacific. What is there? Do you think that will? I guess what was the thought that you had for wanting to backport it?
No, actually, for Pacific, I would even go further, actually taking Igor's PR that had multiple modifications I thought that for master and for Pacific, we will take this, and for further back, if still needed, we just cut to your fix 5 and that simple commit you just mentioned. So it will be just not to make too much changes in back releases.
So before Pacific, we used max blob size of 512K, and we don't hit this. Also, the logic I think is a lot different in that path, but yeah, we don't have the same problem prior to Pacific.
So maybe in that case, we just should only backport Igor's patch to both master and merge it to master and backport to Pacific and be with that, because that's definitely the most comprehensive solution. It encompasses all that the fixes that I know that we had made for it.
Yeah, and I think the changes are not that complex. So the commit itself has plenty of changes with testing and performance counters, but the logic itself wasn't touched greatly, so it's not very dangerous to backport, in my opinion.
So you guys both feel like the patch set from both of them together are reasonable for a backport at this point?
Well, that is still an open question you raised about better performance with 256K max blob size. I did some brief investigation, and I could see some additional deferred writes for without this setting, even with my PR, which probably causes that performance drop. I still do not know the root cause. Maybe it needs some more investigation. So we can wait till this final solution, or maybe make an intermediate merge and then proceed with additional investigation.
Igor, why? I don't know. I don't remember. I think it was part of the work that you had done on the deferred rate path earlier. But why did we switch from a 512K to a 64K max blob size?
I don't remember. I need to check that.
Okay. I think it was part of one of the PRs that you had made earlier, but I should double check on that.
Let me check that offline.
Okay. So, Neha and Josh, you guys have any strong opinions about backporting to Pacific, larger or smaller fixes for that versus what we're going to do in master?
I guess my point of view here is that given that what we have is that we backport, if it does not address the problem we saw completely, should we do a point release with that or not? Or should we hold off on backporting it, just merge it to master, wait for all the follow-on fixes that Igor was talking about, and then backport the entire patch set? And the other question is, are users affected by this currently? The answer probably is yes. So can we do something in the interim which is minimal and just works around the issue until we get the full fix backported? I'm open to ideas. These are kind of the options I'm looking at.
But what I see, the Igor's PR does not really introduce much more logic than what we already mentioned that we want to take. It just adds useful performance counters and minor improvements. So there is no risk with taking the additional parts
Okay.
for now.
Yeah, I get your point. So what you are trying to say is that the current patch set improves the situation already. Any additional changes will be a bonus that come in later. So there's no harm in backporting the entire patch set.
That's my opinion. Correct.
Adam, do you have any strong opinion? I know we're nervous about changing the blob size. Part of me is nervous that we've already changed the blob size.
I have a very strong opinion on changing blob size. I need to see a lot of testing in different conditions because I've seen how much different performance aspects are affected by this value.
Yeah, but my reasoning for it is I don't think we did that when we changed it in the first place, or at least maybe we did some, but I don't know that we know all of the effects of it, I guess.
I'm sure that we did insufficient testing when changing blob size from 512K to 64. I'm just my intuition tells me that there should be some traces of results if we did select this value doing some elaborate testing. I did not see anyone who would remember such testing.
So I think
testing around that with its HDD fixes to make that work better in general.
I know there was a lot of testing, Josh, but did we actually test the blob size changes? That's what I don't know.
I can't remember. I thought we did.
Okay. We've got those somewhere in the Etherpad. I mean, it's possible even too, right? That it could be that that we do see better performance overall, despite having more work being done by RocksDB and more array amplification, and maybe we even want that possibly. We want the improved performance at the expense of maybe like more work being done by the database device.
Yeah, potentially. And I think it's large trade-offs and the exact performance implications to me aren't clear.
Igor, do you also feel fairly confident about your PR going back into Pacific?
Yeah, I think it's safe enough.
All right, maybe that means we should just go for it. What do you think,
So,
Josh?
speaking about max blob size, it was set to 64K for spinners along with other changes for K allocation size. And I'm not sure about SSD setting. Checking that. It seems it has been.
We don't. Right now, we just have it set for 0K. We just don't defer.
Sorry, I didn't catch.
Right now, we don't. We have it set to 0.
No, I mean max blob size.
Oh, sorry. Yeah, I was thinking deferred.
So I think for SSD, we have max blob size set to 64K for edges. For the last commit, touching this line is 4 years old. And well, actually, what I don't like about our current benchmarks is that we perform them against SSD.
I agree with you. I would prefer them to be on hard drive, but it takes much longer, and we don't really have them available for this kind of thing at the moment. Igor, if we ignore the benchmark numbers, the performance, and just focus on the behavior of writes hitting the mem tables and write ahead log, so, and then the behavior of compaction, do you think that's reasonable?
Well, from what I can see in your spreadsheet, the numbers are pretty good with both atoms and my commits. So we fixed this write amplification we had before.
Yeah, we're not quite as good as if we use a larger max blob size. If you look at like the compaction events on line 42.
Line 32.
42, sorry.
42. And which column you are referring?
Column H versus S and T.
Okay, so 100 versus 175. And this difference, is this difference consistent?
It looks to me like when we have the max blob size smaller, the preferred deferred size smaller than the max blob size, we, significantly smaller, we end up with around 100, like in the 4K and the 16K case on C and D. They're also around 100.
Okay, that's expected since the smaller preferred deferred size you have, the less traffic you get into the database.
Yeah, my hope. My hope was.
Okay, go ahead.
My hope was that we would end up seeing that hit the write ahead log, but then we would see that we would be deferring fast enough that we wouldn't end up pushing it back into level 0 for compaction.
Well, maybe we should revise something else. Apply these deferred settings faster. But you see that even when you have 100 compaction events for, say, 16K preferred deferred size, it's larger than the value in column B, which is 0 for preferred deferred size, which means that
absolutely.
Additional traffic still goes out of write ahead log to the database itself. So you still suffer from not everything left in write ahead log.
Yeah, exactly. And all of this is way better than the situation in column F, right?
Yeah. So if we try to fix, if we try to avoid these deferred writes going to out of write-ahead lock, we should probably look at something at some different location and fix something else. So with all these settings, I mean different from zero, we still get additional traffics going, additional data going out of write-ahead lock. So
Yeah.
we wouldn't. So right now we try to reduce the traffic itself, but we can't fight this write-ahead lock spillover.
Yeah, it's and it's not clear that making the deferred the deferral happen faster is good, right? Because you could potentially introduce more seeks that way on hard
Yeah,
drive.
and here we are back to the idea to benchmark against the spinners. Since
Yeah. And so that's why I don't want to focus on the performance, because the performance is kind of misleading. It's more about there's some trade-off between not having too much write amplification in the database and too much work being done in the database versus trying to avoid seeks on the disk. So I think, I think any of these fixes probably get us closer to where we want to be in terms of not having an excessive amount of work being done for big IOs, right? Like that's really what it is. We don't want to defer big IOs. So I think all of these fixes more or less do that, right?
Just one additional observation. So if you before we were talking about compaction events, which is higher for my PR and for the cases when we have deferred size higher than zero. But the next line, which is 43, is average compaction time, and actually it goes down with increasing the amount of compaction
Yes.
events.
And I can tell you why.
Yeah, just want to say that we might want to estimate the overall impact.
It's not actually. It's not actually a good thing, though. It looks good, but what's happening is that because we're deferring very large IOs, we fill up the buffers for the mem table. We fill up the mem table very quickly, and so you have a huge amount of data being compacted in RocksDB, and because there are very few items being compacted, just a very big, a couple of very big items, then the compaction happens quickly, but we do many of them. If you look at the next line on 44, you'll see that it's actually an inverse relationship to the total compaction time oftentimes here. Like in column F, the individual compaction time is very small because we're not compacting very many items, but we're compacting lots of data. And so the total compaction time ends up being very high because we do lots of compactions.
Mm-hmm. Yeah, actually output size is high, and yeah. So yeah, but well, again, it's rather well. First of all, that's probably a matter of balance between performance for spinners and this write overhead to database. And secondly, we might need some to check some additional settings to avoid this write-ahead lock spillover.
Okay. Yeah, I agree with you on that one. So, okay. Igor and Adam, do you think we should backport then both of your PRs? You're comfortable with that, backporting them to Pacific?
Actually, if you backport Igor's PR, then my work is already there.
Oh, good. Okay, and then is there any point to doing fix 5 from my patch series if we do that?
No, that work is already in Igor PR.
Okay. So then it sounds like we'll go for the full enchilada and apply Igor's PR to both master and to Pacific.
I would prefer that solution.
Okay. Is Niha? Oh, Niha, are you comfortable with that, Niha?
Yeah, I think so. And I get where Adam is coming from, and I think it's fair to say that it's better than what the existing specific behavior is.
Yep. Agreed. I think then I think we should still go back and look at the max blob size and try to understand if it did make sense to switch it to okay or not. But it's not necessary.
Yeah.
You know, we'll get most of it back.
Yeah, and also some additional testing with the hard disks is going to be really helpful, so we can see how that we can make that possible.
My hope is that maybe we can get the Red Hat Storage Working Group to, if hopefully we can convince them to retry a couple of their tests to make sure that it doesn't hurt them, but then also
I've already started talking to them about this, but I'm just curious, is there a particular workload profile? I mean, obviously they only test with RGW, but in terms of object sizes and stuff, do you have any preference, or what they did earlier, just do the same, like they have two kinds of profiles, like small objects versus regular size objects? Just doing that should be good.
That's how we discovered it originally, right? Is when they were going through their tests, we saw this.
Yep.
But I think it would be, I think it's fine. We could also do RBD tests on this, but I think the RGW tests will be sufficient to get a good sense of what's going on. And I mean, this is kind of we're gaining this in pretty fast because we need to. But
just curious, this benchmark you performed, were they for RGW or for RBD?
Igor, there were some RGW tests that were done internally by one of the storage groups within Red Hat, and it was just kind of happenstance or luck that that we were reviewing their OSD logs and saw that there was a ton of compaction happening, and that's why then I went back and started looking at it on one of our upstream test clusters to see if it was in Pacific or not.
Why I'm asking, so it I have an impression that all this stuff with preferred default sizes, it's more affected by overrides, and hence GW should suffer much less from these inefficient patterns, because it tends to override the objects totally.
It appeared in those logs, those RGW, the logs of the OSDs from the RGW workloads, that every write IO was being deferred.
But is that assumption correct, that we perform full write every time for GW, or they performed it?
So you're wondering, did they do like a partial overwrite of an RGW object?
Yeah, because again, from both my experiments and the common sense, it looks like this additional deferred writes appeared on other writes, on partial writes.
Okay.
So, but maybe I missed something. And well, for all the writes, and more specifically on a line to the writes. So if your writes are aligned with this max blob size, then they shouldn't go deferred, as far as I understand. But well,
Well, my experiment on simple vstart cluster on my machine, when I matched deferred size with blob size, I could just put a new object size of 1 megabyte and get all of the chunks deferred. So I assume the same would happen for RGW, creating new objects.
Yeah, makes sense. Then probably I missed something, and perhaps I have seen the same. Just forget about it. Okay, never mind.
All right, cool. So Niha, did the tests on Igor's PR pass? Are they done?
Yeah, I think that looks good. I'm just going to paste the results and go ahead and merge it.
Okay, that sounds good. And then you're talking to the workload folks.
Yep. So yeah, once the PR is merged, maybe we can just create the Pacific backport as well and start getting some testing on that. Hopefully, we can. I guess what I'm understanding is there's no issues to get it in the next Pacific point release as well, right?
I don't think so. I don't think there's been any. Well, I guess I don't know for sure, but it seems like it shouldn't be terribly difficult to backport that into Pacific.
Yeah, I don't think there should be any conflicts as such, like too many conflicts. But Igor, Adam, +1 to releasing it in upstream.
Yes.
Yep.
Sounds good.
Cool.
Just a couple of related items. First of all, we might want to create a ticket to additionally investigate this performance difference for max blob size 256 and 64K for max blob size. Just not to miss that. And secondly, we should be careful with comparing master and Pacific now, performance for master and Pacific now, since Gabi's PR is merged and we can get different performance for master.
That's not very problematic because we have a configuration option which is false by default. So in default mode, we still use column B.
I see. Okay. So, and any plans to change that?
You mean change the default?
Yeah.
I didn't put my thought to it, but I think we should.
Yeah.
Because otherwise it would.
Yeah, it wouldn't get enough testing as well, right? Then if you want to, okay, I think we need to decide if Quincy will be released with that, or if our plans are that we want to change that default for Quincy. So we should probably do it earlier rather than later.
Yeah, I'd say now is the time to make it default and then back off on it if we have concerns. There is one other thing, Igor, that I wanted to bring up that I did notice. I have not investigated it yet, but with your
just
PR...
Mark, just a little correction. The default is that we do that we skip column family B. That's the default behavior.
Okay.
Oh, that's a default. Sorry, I made a wrong statement. Thanks, Gabi.
Yeah.
Okay.
Okay, then all good.
So
Igor,
my point about be careful when comparing the performance of between Pacific and Master makes sense.
Yep. So Igor, there was one thing I wanted to ask you about. With your PR, with the one for the deferred write change, I saw that, and I know I'm talking about performance again here, which is a little suspect, but on line 27 of that spreadsheet, column T, the 4K write throughput improved dramatically. And I was just a little concerned looking at that. I haven't investigated, but I was a little concerned whether or not in your PR small writes were actually being deferred, or if it was acting like the 0K case where we're not deferring at all.
Well, first of all, I'd like to say these are not small writes in our terminology. So 4K is still big. Everything less than 4K goes to small write logic. Why it became better? Well, they should go deferred anyway. And why it happens that better?
Historically, it was always better when the preferred deferred size was smaller than the max blob size. And none of my changes fixed it, and Adam's change didn't fix it, but your change apparently did.
So, well, actually, if you take a look at column C, D, or E, performance is the same. And
exactly.
Honestly, I don't think that 4K write should have different logic when so they shouldn't depend on the max blob size or preferred deferred size. So no matter if you have 64K preferred deferred size or 4K, then the common sense says me that it should work the same. So I presume we just have some misbehavior with larger max blob sizes, which I fixed. I can double check what happened before, but I expect this to go deferred, and I just cleaned up some issue.
Sure. Yeah, it's nothing wrong with your PR. It's just that it makes it appears to fix something that neither Adam's fixed nor my test did. So.
Yeah, but well, again, we can still see the same performance numbers for non-zero preferred deferred size. So.
Yep, and then as soon as the preferred deferred size equaled the blob size, that's when it dropped.
Yeah. But I'll take a look why it was worse before.
Okay. Cool. All right, anything else, guys?
I'm just wondering if I should somehow move priority with. I have a plan to make a modification for that will allow to test HDD performance on SSD, meaning that you could run some test for a long time on SSD, just filling a cluster and simulating long operation fragmentation and stuff, and then just switch for HDD to actually get for a short time, like 10 minutes, 15 minutes, the performance of the solution. Should I really make it some more priority, or it's not really urgent now? Because I had it in not really urgent, but now I'm not so sure.
So you just artificially insert latency to simulate seeks?
No, the intention is to have a setup where you have actually HDD mirroring SSD, and you, for a time when you're filling a cluster, you just operate on SSD, but when you have testing mode, you force HDD to actually do operation, read, write, seek, everything as it should, but drop the data and feed the data from SSD anyways.
Oh. You'd actually have a physical HDD then, or would you simulate it?
Yes, in that simulation, there will be a pair of HDD and SSD simulating one device.
I thought you meant you would have SSD, and then you would insert extra latency for operations at low levels.
No, I'm too incompetent to actually predict remake a drive logic that tries to be the fastest as possible. That will be too difficult.
Okay. The only problem we have is that our only machines that we can test on with hard drives that I know of are Incerta.
Yes, but is that a problem? I mean, I have to upgrade Incerta 7 to CentOS newer, because that's problematic to compile anything there.
Yeah. No, it's not necessarily bad. It's just I think we've got 4 of them being used for Jenkins now. You've got one, I've got one still, which also needs to be upgraded. And then I don't remember who has the other 2. I'll have to look at the list. But
so the question remains, should I speed it up, or it's not really necessary now?
So if I'm getting the idea right, Adam, you are kind of trying to simulate the same that most of our users have, right? Their metadata on SSD and actual data on hard disks, which is not something we get to tautology coverage. No?
Not at all. I'm just talking about simulating spinner, but for the sake of compressing a week or 2 weeks of operating on HDD, because that takes a lot of time, and fragmenting data, that period will be compressed to, let's say, 1 hour using SSD. And when your cluster is properly fragmented, has done some actual work, then in test mode, reads will be done from actual HDD. All that necessary sectors will be read or written to, but the data from that will be dropped because there will be no data there, and the data will be provided from companion SSD that was used before. In that way, I intend to make long duration tests in hour or something like that.
Yeah, now I get the idea. I think it'll be useful. That's something we don't get coverage of, right? Long running test and already degraded state, fragmented state of the cluster.
This is it stems from the question that some time ago Igor asked me on a PR if I did actually testing on Spinner, and I understood that testing it would take like a month or so. So instead, I came up with that solution that's still not finished the simulator.
Mm-hmm.
Not
Yeah, I
started.
think we should. Igor, Mark, what do you all think?
Maybe a bit different idea. What about filling the cluster? This wouldn't work, but maybe it worth additional thinking. I mean, in this prefill state, you might avoid writing data to the disk, but instead fill just metadata. So hence, you do not perform much writes to spinners. And then enable when you switch when we come to the actual testing phase, you enable writing to the physical disk and proceed with your testing. Hence, your prefill state would be short enough, and you might disable checksum verification and hence avoid disk read errors. The only drawback I can see for now is we still need some writes for service data. So not every data write could be bypassed in this prefill mode.
That will be good for me just testing on my desktop, but such solution I couldn't share with any group that tries to use RBD on such solution. It will just not work.
Okay.
Adam, I just posted a link in the chat window. Your topic made me want to go look and see if anyone else has ever made a simulation of hard drive on SSD. And there's apparently these device mapper delay targets that you can create.
Okay, thanks. I will read into it if it's applicable.
Yeah, it might not be the same thing that you're thinking of, but it might be something that we could use to take a machine that only has SSD drives and then make pretend hard drives on them. All right. Well, I think we're over time, guys. Anything else? Well, have a great day, everyone.
Thanks, man.
Thanks, you too.
Thank you.
Bye.
Next week.